Can you shut the door? I just have to hit the record button to guarantee somebody's going to walk through within 30 seconds. Anyways, all right, folks, welcome to week 5. Today's edition for um, it's covering stuff that we covered at the beginning with a bit more detail. The good news is that as of today, make sure there's no use this. But I'll go for after I'm done. So, on nothing now, you've been looking at today's presentation. You notice I didn't open up a command terminal because it's that command. Right? So there's no point me just typing stuff in. So basically, they're made on both columns. That's nothing new. However, when we talk about creating database tables, we tend to want to cover a topic called data integrity. Data integrity's purpose is to make sure that you protect your data against unauthorized security issues and meat sack problem. That's the problem between the chair and the key. Because humans are usually the biggest source of data issues because humans are not reliable. You'll never have two humans do the same thing the same way. Therefore, you want to design your database in such a way that you limit the ways a human can screw up your data. So when you talk about databases and data integrity, there's 4 kinds of data integrity. The first one is entity integrity, which is defining primary keys. That makes sure that data is always unique, no matter how it goes. In certain parts of the world, there's certain names that are common, and you'll have common names that you can't use that as a way of identifying someone. Wings in Vietnam, for example, Patels, Mohammeds. Those are very common names in different parts of the world. And you can't use those as primary keys, so at least having a true primary key will help keep things clean. Referential integrity, also known as foreign keys. It makes sure that when you create relationships between objects, they tend to only have valid values go in. Domain integrity. Now, here's 2 quick examples, null and check constraints. Domain integrity also goes down to the data types that you use. In other words, you got to make sure you can't type letters into a field that expects numbers, that kind of thing. And then there's something called user-defined integrity, where you can create functions and stuff to set up your own rules. I'm not going to worry about that this semester, and even. Okay. Okay, well, I literally just finished explaining that while I was talking through the first set of slides. All right, so when we talk about data integrity, and if we look at a few examples, these are screenshots from DataGrip. For example, we have an employees table, and we have an employee number set as a primary key. You'll notice that the birth date is set as a date, not as a string. They got a little creative with the gender. Instead of using just a standard character field, they decided to use an enum. And as you can tell, this is a really old example because it only gives you 2 choices. So what an enum does, it says it's only allowed to enter one of the following list of values that will be accepted. If you try to give it anything else but those accepted values, it just blows up. It also has 2 check constraints, age and net income. Age checks to see if they're over 17. And the net income makes sure that the overtime is less than their salary, based on this example. Those are examples of check constraints that are user defined. You can set up rules that are not just typical rules in the database that you'd expect. Um, Other examples in here, there's an example of an index that's set up to be unique. Even though the department number is the primary key, you don't want to have the same department name show up more than once, so you can create what's called unique indexes. And those basically, it's a rule that says values cannot be duplicated in this field. Common places that unique indexes are used. Usernames. So if you've got a website or an application that has usernames or email addresses, often those will be unique because you don't want somebody registering with the same thing twice. You don't want two users with the same username because that can cause all kinds of chaos. So that's one of the other kinds you can see. All right. So referential integrity is a series of processes built into the database that's used to make sure that relationships stay sane. By staying sane, I mean the child table only receives values that exist in the parent table. You cannot delete a value from the parent table while it's still referred to in the child table. If you want to get rid of the parent record, you got to nuke all the children record too, or change who their parent is. There's a few ways of handling that case. It also makes sure that there's only a limited set of values that can go into these fields. Often for that would be um, common things you'd see for this would be countries, a list of countries. You don't want people randomly punching in countries. It's not great. I have a bit of a story on that. Another one would be titles, Mr., Mrs., insert your title here. Um, Shipping methods, order status. You don't want people getting creative and creating new order statuses or new shipping methods because, well, you don't want random bad data going in. Now, going back to the country example, I don't know if I covered that with you guys, this particular little story. So at my second job in Ottawa, so after I'd moved here, I was here for about a year and a half. I got hired by a new company, and they had me writing reports from website registrations. Now, hang on, this is back in the wild west of the internet. By wild west, I'm talking like year 2000. Internet was around. Internet was starting to look nice, but people really didn't understand how to interact with the end users because they assumed their end users are actually not as stupid as they really are. And they allowed in their registration form free form text field for name of country. They didn't pull it from a list. It was coming, whatever the person typed in. So they asked me, can you pull out all the North American user registered? Cool, no problem. Okay, so apparently there's three ways to write Canada. C-A-C-A-N-N Canada. But that was the easy one. Stupid Americans. US, USA, U.S.A. dot. U.S. dot. United States, United States of America. Yeah, I had to find every version of United States, and that was including the ones I didn't put in typos. They wondered why it took me 3 days to write this report, because I literally had to crawl through row by row to find every version of the United States. And the very next thing I did is rewrite that web page because it was terrible. So yeah, that's why you want to use referential integrity, is to make sure that only valid values get shoved into the database. All right, so how is referential integrity established? Well, I already showed you guys how to do this code-wise, where basically you create a constraint. But in a bit more detail, there is a primary key and a foreign key, 90% of the time. There's always the exception to the rule, but actually not even 90%, I'd say 99% of the time. So the primary key is the source record, the foreign key is the destination record, and the value in the foreign key must exist in the primary key that it's pulling from. Essentially, it establishes a connection between the two. So when you look at data grip and you look at table structures, you'll see primary keys and foreign keys, and they're listed. Data grip does a really good job of demonstrating it right in the UI. For example, you'll have the country code pointing to country code. So in other words, it's saying that the field in city called country code must exist in the country table in the code column. So when we look at the country table, code is the primary key. So it's saying that any values you put in country code must exist in the country table's primary key. We cannot create a new country code. That's essentially what that rule is. It's back to my example that I had earlier where we just let people type anything in. Didn't go well. I forgot somebody actually drew on this originally. Okay. Um, so when you add primary keys, there's two ways of adding them. The inline method is the quick way, but it has some interesting side effects, especially when we deal with MySQL and MariaDB. So the quick way is you list the fact that the primary key is part of the column definition. In this case, country code, car3, primary key. And at that point, when the table gets created, it will create the primary key and it'll be assigned to country code. A few other things you'll see in here is an enum that lists that the continents can only be Asia, Africa, or America. Apparently, Antarctica doesn't exist, and Australia doesn't exist, and Europe does not exist, right? But let's just say that when you go to put something in this, it must be one of those three continents when you punch it in. It will not accept any other values. Now, depending on what database server you're working with, that'll even be case sensitive. MySQL is not, but if you work with Postgres, for example, or Microsoft SQL Server, it might go and say, no, it has to be exactly Asia with a capital A, not lowercase Asia. Uh, so when it talks about not recreating the primary key when reverse engineering the database, reverse engineering is when you use a database tool to create a diagram of that database. Sometimes you will get hired, you're working in an environment and they do not have an actual diagram for you to work with. You have no idea what the database looks like. So all you have is the raw database. There's many tools out there that'll do this. You connect to the database and it actually asks the database server for all the metadata and all the table creation information. It actually creates a diagram for you by basically instantiating the database inside itself. Now, MySQL Special, if you create it this way, sometimes it doesn't actually create the primary key in a way that the database tools will recognize. On the other hand, you can do it the explicit method. The explicit method is required, for example, when you're creating a table with a compound key. So that's the case of you have a table where you have a primary key composed of more than one piece, more than one column. Now, that being said, some database servers will let you go country code car3, primary key, state code car3, primary key. Some of them will let you do that, but it's not guaranteed. Therefore, if you want to have a proper compound key, you need to do it this way, which is after you've defined your fields, you add another comma, and you just say primary key, and you list off the columns, comma delimited, that make up the primary key. In this case, the primary key will come out and have two elements in it. That means that both country code and state code are required when you add a row, and the combination of the two must be unique. So, for example, if we did country code CAN, and then the state code was ONT, that's unique. Then you did CAN PEI, that's also unique. But I couldn't put in CAN ONT a second time because that combination is not unique. So that's what the compound key will do. All right, now to define the relationships a little bit. So The most common type of relationship is one-to-many. That's basically what we're going to talk about today. You can create the relationship when adding a new table or after using an alter table command. So the relationships can be created at table creation time or later once you realize that, hey, the design suddenly discovered that we need to add another column and it's going to be pulling values from a new table we just created. For example, I don't know, you have a list of customers and then suddenly the company you work for wants to assign customers by division. Suddenly, but your original design didn't have a division tied to the customer, so you'd create a divisions table and create a new column on the customer for the division ID, and then you'd assign the primary key. The customer table is already full of data. You can't just drop it, recreate the table with the new column and relationship, and then hope it's all going to be good. What you do in the end is you add the column and then create a foreign key. So back to the country and city table example. The country code again is the primary key. I already talked about that. On the child table, you'll notice that the constraint is defined as part of the table. So after the last column is defined, you go comma, constraint. With foreign keys, you have to name them. The name is not important as long as it is unique to the database. On some database servers, it only has to be unique to the table. MySQL, MariaDB, it has to be unique to the whole database. So constraint, name of the constraint. Then the constraint type is a foreign key. And then you open up the parentheses and you say, what is the column that's participating in the foreign key? Actual fact, there's a typo on my slide that I didn't notice before. Let me go fix that. That's gonna actually work now. I was referring to the wrong column because that column didn't exist. So foreign key, country code, references the country table to the code column. That's actually something you saw earlier in the samples from DataGrip. However, you'll notice a little bit more after that. Now, cool tip. You could stop at the point where you say references country code. Bang, and you're done. That allows you to additional rules. If you don't include that next little bit, it'll do whatever the database server does by default, which is basically this. So on update cascade, that means that if you were to change the primary key in the country table, so country code Canada suddenly becomes country code USA, what that would do is it would reach into the child table and update all the foreign keys to match automatically. So anything that was Can before suddenly becomes USA. That's what that does, the cascade. The on delete cascade is really, really freaking dangerous. On delete cascade says if you delete the parent, the children will be deleted automatically. Instantly. No questions asked. It's not even going to warn you. It's a drive-by shooting. Like there's no warning at all. So if you do an undelete cascade, and by the way, that is something that is not done with data of business value in production systems. You never allow undelete cascade because you could theoretically, if you accidentally delete a customer, you could delete all their purchasing history and magically suddenly you have more money in your account than you're supposed to have because you no longer have records proving that the customer gave you money. So undelete, there's a few different choices. Actually, update has the same thing. There's the option for null, which I think is actually going to be on one of the other slides, but I'll talk about it now. So the cascade, null, or do nothing. So cascade means go down and apply it to the child records, whether you're changing the values or you're nuking the record. Parent record, the child record will be set to null if it allows nulls. In this case, it would. But if you were to allow nulls in that field, on delete of the parent record, the child records would be set to null. These in the database industry are known as orphan records. And we don't finding it using that relationship suddenly will no longer work. The problem is that those are still living in the database, doing whatever they're doing, but they're no longer connected to the appropriate things. Um, in production system, the behavior, nothing. So on delete, do nothing. That means that, oh, you tried to delete the parent? Oh, there's children. Sorry. They're not allowed to do that today. That's literally what it does. It stops delete from ever happening. And here's the explanation of what I just finished talking about. So the on delete cascade, and it doesn't talk about the other choices of um, do nothing or null. Um, so databases are aware of the relationships. If you were going to, an example some of you may have already experienced is you try to insert a record with a duplicate primary key when you were doing lab 2, I think it was, when you were inserting records, or lab 3 when you're adding data. You try to insert record with a primary key, it'll complain. And that makes sense because what's the point of having duplicate primary? Point of having a primary key if you can have two of them. It'll do the same thing with foreign keys. You try to delete a row in the database that is that has a child record. It's going to say no, you're not allowed to do that. Here's an actually perfect example. This one's the other way around, where you try to add a row into the database, but the so in other words, it's saying, hey, you try to put a value here, that is not valid. All right, so that literally covers everything for the midterm. Now, few pieces of housekeeping. All right, I have put up a exercise for the midterm assessment. You should be able to see it. It's going to be under midterm assessments. It literally is all there. Um, this is literally a practical assessment from last semester. It's just not the one you guys are doing. Therefore, it's very real. I had 28 students do this last semester, this exact one. That's that one. The other one is Lab 5. Um, Lab 5 is a chunker, as they say. It's hard. The thing is, it's basically the practical assessment on steroids. So what I would recommend for you guys to do is do the practical assessment first. And if you feel comfortable doing that, then do Lab 5. Lab 5 is not due until the 23rd. Second on the screen. It's not 23rd. I just wanted to pull up the calendar just to, highlight that you literally have over 2 weeks to do it. Lab 5. Lab 5 is, you still have to do it. It's just literally the practical assessment with many more steps. So it's really good practice for the practical assessment. If you can do Lab 5 in under 2 hours, you can do the practical assessment in under an hour. Um, I mean, you can do the practice. That one will give you a good baseline of how well you know the material. And it's literally create a table, add a couple of rows, do a couple of select statements from one of the databases. It's not a big practical assessment, but it covers a bit of everything you've done. The other topic is the midterm test. Yes, it's going to be on paper. The edict has come down that I cannot use the Brightspace test. Cool. There's only 28 of you total. I'm not even bothering fast hand that I can, waiting for the test center to get back to me. Because if I do the test with you guys and I drop it off at the test center, it would be dropped off whatever at 6:30 at night. I probably wouldn't get the results until Monday. Therefore, I might as well just sit down with a beer on Saturday and just go through the tests, right? And you hope you're more towards the end of the tests. Actually, 28 tests is not going to take me long. Uh, I'm really surprised they don't. Actually, you know what? I bet you there is one. The school just won't pay for it. Um, yeah, no, I mean, I used to hand grade my exams for when I taught another course where I had over 140 students, because I used to hate Scantron so much, and then I got lazy. Um, yeah, so the test. I'm going to go through the breakdown of the questions next week. I don't do a detailed review. Why? Because I record my lectures. If you're not sure about something, you can go back and watch my lectures, right? So what I do is I say, okay, you are going to have. So I can tell you guys right now, it's 30 questions, multiple guess. There might be a few fill in the blanks, but literally it would be like one word answers. You know, what's the command that does this? What's the command, or what would be the appropriate data knocked out? Okay, that would be multiple choice, but there'll be a few fill in the blanks kind of questions in there too. Nothing big, nothing too cruel. I don't believe in cruel exams. Considering we only have an hour to do it under the best of circumstances, it can't be more than 30 questions. Now, the so we have literally technically have 50 minutes for the test because we have to clear out 10 minutes early, right? And half the people always show up late. So, those people have even less time. Don't be late. So some people wonder, well, why is it 30 questions, not 20 questions or 40 questions? There's actually standards in how long you're supposed to give for questions. The Canadian standard or the Ontario standard for university for a multiple choice question is soft up the question. No, it's not. If you know, that's the standard for university. Okay. The college standard is 55 seconds because they assume most college students don't have the reading skills of university students. Whatever. Just saying. Um, I don't know. It's just what it's always been. Well, the reason why 30 seconds isn't that bad is if you know the material, you'll go through a lot of the questions in under 30 seconds, which means that if you do questions in 20 seconds, you're getting 10 seconds a question more towards the questions you have a hard time with. So it balances out. Um, Now, personally, what I tend to do is give more than that because I've usually have so many international students where English is not their first language. I tend to be a little more understanding of such language challenges. I've had enough Canadian students that can't even read the questions properly, that have no excuse not being able to understand the questions. So I give normally about a minute and a half a question. So if you look at 30 questions, minute and a half, that brings us to about 50 minutes, well, 45-ish. So it ends up being a fairly fair time for everybody. And this one here is going to be pretty easy. You're just literally just going to go test. You're going to go circle, 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 circle. You don't even have to worry about transcribing to Scantron because that can add another, 15% to how long it takes somebody to do a test. So it'll be in class at the normal class time. I'm not making you guys write a test at a different time. On paper, so no Scantron. That means you get to use a pen if you want, or pencil. I don't care. Um, I will be taking attendance. The only time you'll ever see me take attendance, as long as I remember the stupid attendance sheet. Specifically, we're told to take attendance check-in, check-out times because it's something we can keep track of. for interest, how long did it take them to write this test? Because if everybody finishes the test in 20 minutes, that means the test wasn't hard enough. If everybody goes right to the end, that means the test was probably too hard or badly written. So it'll be 3 questions, 15 minutes on paper. People are going to be spread out. You don't get to sit on top of each other. Sorry. Um, and then, unfortunately, just the way your schedule is, as soon as you're done panicking about the written test, we get to all scurry down the hallway to T building to do your practical assessment. Um, and it's just unfortunate. Normally, I almost never have a class on the same day as the lecture for the lab. That's just how it went for you guys. But if nothing else, it's over with. And one is practical, one is theory, so it's 2 different sets of knowledge anyways. So it's just like a long comprehensive test. The practical assessment is an hour, 50 minutes long. I am going to try to convince that prof that's in there till 7 o'clock every week to get out 10 minutes early so you guys have a chance to settle in. I don't expect that to go well, but I am going to politely ask him to get his ass and his students out the door on time. Okay. Outside of that, that is pretty much it for the before whatever. So like I said, for lab 5, you guys have 2.5 weeks to do it. If you want to come to lab because you have problems, knock yourselves out. If you don't feel like coming to lab because you think you've got this, cool beans. The only time in the next 2 weeks you need to come to lab is on the 20th. Because you don't come, because you're going to be signing an attendance sheet, and if I see that you submitted something and you didn't sign that piece of paper, I'm going to assume you weren't here and you were sitting with your friends working on it together. Yes, I've seen that. Um, just pro tip, Brightspace does tell me what the IP address is of where you submitted from. And I do happen to know what the internal subnets are at the school. So if you're coming in with a, you weren't here either. So I've got a couple of ways of verifying that. So you must come in person. There will be an attendance sheet that you're going to sign. Again, I hope I remember to bring the damn attendance sheets. It's happened before, I forgot them. And what you're going to do is you're going to create an SQL file and you're going to submit it to the midterm assessment submission box. And I take your file and I run it. Then literally, that's how I'm going to grade it. I'm going to go copy, paste, run, see what happens. Hopefully you give me a file that runs, because then you have problems. A different kind of problem at that point. All right. So that's about it. I will dismiss you guys now. You guys are free to run. I'll see whoever comes to lab. I'll see you in lab. If you don't come to lab, go enjoy your evening, folks.